first question, it's actually very easy. It says they're giving us the IUPAC name, the Okay, let me just move it a little bit this side. We have the IUPAC. Now remember, I just want to write this in green. Let's use green. What IUPAC means? It is the international. It is the international, and I'm going to explain what this means. Union of pure, and someone going to write it here, applied chemistry. Applied chemistry. Now, in an exam, what the examiners like doing, they can ask you, they can give you a molecular symbol, they can ask you to please give the IUPAC name of this molecule, or they can give you the IUPAC name and then ask you to name it. But now remember, when we are talking about chemistry, it's a universal language that we all use. So if you go to a different country and so forth, they will use the same system in order to name organic molecules. Now, it's not just something scientists just woke up and thought about. Remember that? We use a specific system on how to name. We look at the longest chain, we look at the side chains, we put in alphabetical order, we look at the homologous series and the functional groups. And this whole procedure on how we name these organic molecules is what we call the IUPAC name. So they can ask you to give or maybe write out what the IUPAC name means, or they can ask you what is the system used to name organic molecules, and that is the IUPAC name. They can also ask you to write the acronym, which is IUPAC, IUPAC, or they can ask you to write the full name. So make sure that you have both. So in this case, they're asking us the IUPAC name of an organic molecule, IUPAC name of an organic compound. I know we have to write everything just in case somebody does not have the paper, so you know where the questions come from and you can go through it with me. We've got 4.4 dimethyl pent 2YNE. And then they're asking us, here this is 2.1.1, and they say write the general formula. Write the general formula. The general formula of the homologous series. The homologous series to which this compound belongs. And this was going for 1 mark. Now, guys, you must take note that when we are looking at the homologous series and the functional groups, they all have something in particular. For an example, I always use this example. You get tea, right? We know all over the world there's tea, but there's green tea, there's chamomile tea, and so forth. So that's what makes it distinct. But all of it is tea. So it's the same thing when we work with organic molecules. All of them have a general formula which they come from, but then the number of carbons will change, the number of hydrogens will change, but there is something specific that makes it the same, which makes it an alkane, alkene, an alcohol, or a carboxylic acid, and so forth. So that's what they want to look for. But now you're going to ask me at tops, how do you know what homologous series this belongs to? They've given us the organic compound name. We've got 4.4 di. Let's think about it. Di just means 2, and methyl means this is a subchain. Pent means there's 5 in its longest chain. On the second one, there is a triple bond. YNE means it's a triple bond. Now, the general formula where there are triple bonds is this one. We have CnH2n minus 2. And this is the general formula for which this 4.4 dimethyl pent 2Y actually belongs to. So for 1 mark, they just wanted you to write this formula. If you were kind of confused somehow, you can actually draw yourself an organic molecule, remove 2 of the hydrogens and actually make it a triple bond, and then you'll see how many hydrogens and carbons you have there. But that was the first question. Very, very easy. Let's look at the next question. Let me close it up to here. So the next question it says the structural formula. They want the structural formula. Now, with this question here, most of you guys make silly mistakes. For an example, you don't find the longest chain or the side chains of the compound. And this was counting for 3 marks. Now you must remember, when the examiner is going to ask you to draw the structural formula, guys, one of the biggest mistakes that you guys do is that, number one, you forget to put your hydrogens. You can't just put the sticks around the carbons. That is not an organic molecule or compound. You have to put the hydrogens around the carbon to indicate to the examiner that you know what is an organic molecule. Number 2, you must find your longest chain. And what I always say to my children, once you have drawn the structure, see if you can rename the structure and see if the name you've given it actually matches with the name that you were given. So let's name the structure. Let's do it together. So I've got 4.4. Now, step number 1, the longest chain is pent. Now, how do we get that? It's eth, meth, prop, but, pent. Pent means there's 5 carbons. So I'm going to have 1, 2, 3, 4, and 5. And then on the 4th carbon, so now I'm just going to number it. I'm just going to write my numbers here. 1, 2, 3, 4, 5. So you could have actually numbered it in any way. So on the 4th carbon, I've got di. Remember, if something is alone, we say mono. If there's 2, it's di. If it's 3, it's tri. If it's 4, it's tetra. So in this case, we've got 2 of the same on the 4th carbon. So where's carbon number 4? It's this one. On the 4th carbon, I've got 2 of the same, and what is it? I've got meth. Meth is 1. So I've got 1 carbon, which is going to look like that. I'm going to have another carbon there with the hydrogens. And there we are. Let's see what else. On the 2nd carbon, I'm going to have a triple bond. The 2nd carbon, I'm going to have a triple bond, and I'm just going to have it there. Now, remember, your carbon, remember, if you take it back to grade 10, carbon on the periodic table can either give away 4 electrons or it can accept 4 electrons. Meaning for it to complete its octet rule, it needs 8, but it already has 4. And remember in grade 10, we learned 1 little stick means 2 electrons. So this means the carbon must have 4 sticks around it. If 4 stick means 2 electrons, it's 2, 4, 6, 8, which means carbon has followed the octet rule. This is what we learned in grade 10. In this case, once you've drawn your organic molecule, you must make sure that in each and every carbon, there are 4 sticks around it. Otherwise, it does not make it an organic molecule. So let's start with the first one. I've got 1 stick there. I'm going to need another one, and another one there. Look at this carbon. I already have 1, 2, 3, 4. With this carbon, I already have 1, 2, 3, 4. This carbon, I've got 1, 2. I'm going to say 3 and 4. In this carbon, very important, I've got 1. I've got 2, I've got 3, I've got 4. I am not adding another hydrogen because I already have 4 sticks attached to that carbon. Let's look at number 1. I've got 1, I've got 2, I've got 3, which means I will have to have another one, which is 4, right? There we have that one. So this is then how you'll have to name that organic molecule. Remember to always count everything that you will have around that molecule. Let's see if we have named this one correctly. My longest chain is 5, which is 1, 2, 3, 4, 5, which is pent, right? And where are my side chains? On carbon 4, I've got 4, and again on 4, I've got another side chain, 4.4. When we've got 2 of the same things on the 4th carbon, what do we call it? We call it di. What is on the side chain? We have methyl, and then we've got pent, and then where's our double bond? Our double bond will have to be on the 2nd. There, this one must not be here. It must be on my 2nd carbon. That would look there. There we are. Don't kill me. There we are. So then I must just remove these ones here to make it correspond. There we go. I just miscalculated there. This one's right. That's 4. This is 4. There we are. Dimethyl. And then on the 2nd carbon, which will be 2YNE. So this is my 1st carbon, my 2nd carbon, that is where the double bond is. So this is what they wanted us to do. They wanted us to draw the structural formula. So you get a mark for having the correct structure, having the correct side chains, which are your methyl, and then indicating that on the fourth carbon, there is 2 of the same. So you have to have 4.4. If you only have 1 4, it means there's only 1 of that thing on that fourth carbon. And then you have to indicate the side chain. The way you could have found this one, you always have to find your longest chain. This is what I always teach my kids. Find your longest chain and then work with your side chains from then on. Okay, let's do another question. Let me see if I have space for this one. Let's go to another slide. So now the second question says, so this is 2.2. It says the organic molecule, the organic compound below, it has 1 positional. It has 1 positional isomer. Now this is very important. Positional isomer and 1 functional. And 1 functional isomer. Now, guys, you must now, when we come to isomers, you need to think a little bit differently. The organic molecule, the number of carbons and the general formula does not change when we talk about isomers. But what does change, the name can change. We can even change the type of homologous series in which this organic molecule is. So, for example, here we've got positional isomer. Positional isomer means the position of something might change. If Tobile is sitting here and then I'll go sit there, I'm still sitting, but I've changed positions. And then I've got a functional isomer. Now we know in organic chemistry, we've got functional groups. And these functional groups are what makes these organic molecules distinct to that particular or specific group. So it means that the functional part of this organic molecule is that what will then change from one to another. But there are 3 types of isomers that you must know. And unfortunately, guys, in an exam, they can ask you to give the definition or they can ask you to identify what it is. But in this case, they've just told us that it has 1 positional and 1 functional, and then they're going to ask us a question. But before we go to that one, in case you don't know what isomers are, let's work through that. We know we've got things like structural isomers. When we talk about isomers, the first one is the chain isomer. And remember, this one has the same molecular formula, but a different chain. This one is the positional isomer. Do not mix these ones up. Let me just say, make it a plural. It also has the same molecular formula, but different positions of the side chain. And this is the functional. This is the functional isomer. Same molecular formula, but a different functional group. So now with this question, it says organic compound below, and now they've given us this organic compound. Let me just draw it quickly. Let me see, it's got 1, 2, 3, 4, 5. We've got 1, 2, there's a double bond O there. We've got 3, 4, 5. Remember, if you do not have your hydrogens around the carbon, it does not make it an organic molecule. This carbon already has 4 around it. So I'll just add to this one. Now, already looking at this, I know that this is a ketone, right? So now, guys, one thing I can tell you, when it comes to aldehydes and ketones, the examiners can try to trick you. So what I've most of the time picked up with question papers like this, they like using alcohols and carboxylic acids, and they like using ketones and aldehydes, right? Because somewhere, somehow, there is something that is almost similar to them. For an example, when we're looking at this one, we've got a ketone, right? How do I know this is a ketone? I always say this. A ketone has got an alcohol in the center of 2 carbons alongside of it, whereas an aldehyde has got a double bond oxygen at the end of the carbon. So it's usually at the end or at the first, right? But depending how you name it. But these are the difference. But now, if you were to move this O to the end or to the beginning, it definitely just changes a lot of things. It can move it from a ketone all the way to an aldehyde. So now, let's see what the question says. The question says, okay, the first one, they love definitions. And remember what I say, you cannot fail definitions, my darlings. You cannot fail a definition because you were lazy to read. These are the free marks that you should get. And I mean, think about it. If you can get all your definitions right, the term, Tobile can multitask, positional, let me finish this, positional isomer, and this was going for 2 marks. If you can get the marks for all your definitions, you can actually bank almost 30 marks in an exam. So here they say define the term positional isomer. So let's just write it out. So it is compounds. It's compounds. I just want to stress when we talk about the word defining. Guys, when they say you must explain something, they like using the words explain mostly in physics, which is paper 1. They're going to say explain what do you think is the motion of the car, right? When you are explaining something, you are giving your visual understanding of what is happening or what you think is going to happen, but you are using the laws of physics or the rules of physics to explain or support your answer. When they're saying you must define something, a definition does not change. You cannot look at this textbook and then you look at this textbook and then it's a different definition for all these things that are supposed to mean the same thing. A definition remains the same, which means you must know these definitions off by heart. Something that I used to do when I was in school, I used to have a notepad where I had all my definitions and I used to use color. So for chemistry, have it in pink. Every time you're in the bus or somewhere, read through your definitions because unfortunately you must know it off by heart. If you do not have certain words in this definition, even though it might be correct, the examiners cannot mark it right. In this case, if we're defining a term positional isomer, we have to say it's compounds because we are working with organic compounds. So it's compounds with the same, they have the same molecular formula. So I'm going to finish it here, same molecular formula, and this is true because what did we say? That the formula remains the same, the number of carbons remains the same, and the number of hydrogens remain the same. However, the position of where they are can change, the length of the chain can change, and it can even change the function of it, or the functional group might change. So it's compounds with the same molecular formula, but different, and this is the key word, positions. Remember, if Tobile is sitting on a chain, she sits somewhere else, she's just changed positions. Positions of the side chain. What changes? It's the side chain. There's an I there. Or the functional group. The functional group. Or the functional groups. On the parent chain. On the parent chain. So guys, I would love us to go through all of these ones, the chain isomer and functional isomer, but otherwise in your textbook, once you've done watching this, go on your notes and then define what is a chain isomer and a functional isomer so that you always know it. But in this case, to define the positional isomer, it's compounds with the same molecular formula but different positions of the side chain and functional group of the parent chain. So let's see what the other one says. Let me sum my work here. Just that we're going to need the structure, so I don't want to work too far from the structure so we can actually look at it. So it says for this compound we must write the IUPAC name. IUPAC, the IUPAC name, right? For this isomer. So it says write the IUPAC name of its position, of its, oh I see, positional isomer. Positional isomer. So now let me show you guys. Let's actually have the structure here again, and then I'm going to move it around. Oh, let me work on this one. So let's change this position here because they said that the functional group of it can move. Now, if this had to move, let me see what would happen. Let's name this this 1, this is 2, 3, 4, 5. So let's say I was to move this double bond O onto this carbon. I'm just going to write an O there and make that a double bond. This means that this O will sit on the third carbon. If I was to renumber this the other way around, let me use another color. Let me number it here. 1, 2, 3, 4, 5. This O is still sitting on the third carbon. If I was to move this O here, it means now I've numbered it in this direction. 1, 2, 3. So this will be the second one, and it's also the second one here, which means I cannot use this one. This only has one positional isomer. If you still don't understand that, I've got 5 fingers here in front of me. This is finger 1, 2, 3, 4, 5, and it's sitting here. If I was to move this one here, this will always be my third finger. 1, 2, 3, or 1, 2, 3. It'll always be my third finger. If I was to move it here, it's 1, 2. It's exactly as when it was sitting here. 1, 2. So it can only have a different number or position on the side chain when it's on the third carbon. So that is the positional isomer that we have for this one. So now let's draw this positional isomer for it. Let me just redraw it so you see, because I've made so many changes on that one. 1, 2, 3, 4, 5. So I've moved it to the third one where there's a double bond O now. And then I've got, okay, let me not say write hydrogens, my darlings, and then I don't write the hydrogens. There we have hydrogens and so forth. Got another hydrogens here. So in this case, they said we must name it. Now let's think, how do we name it? There is 5, which is pent. I can see that this is going to have a name own because it's a ketone. How do I show that? I can say pent because it's the 5th one. Remember, when you are naming organic molecules, according to the IUPAC naming system, a comma and a hyphen means completely different things. Between a name and a number, we have a hyphen. But between two numbers, we have a comma to show, like on the previous example, it was 4.4, meaning on the 4th one, we had 2 of the same, right? So do not put commas where you're not supposed to be putting commas. Unfortunately, the examiners are going to mark that incorrect. Remember what they're wanting to see? They want to see if you understand the IUPAC naming system. For an example, if you decide to pursue chemistry and you go and you study abroad and all that stuff, you should be able to read the chemistry language from that university and their textbooks with ease. Because physical sciences is a language on its own. We use our own genre, right? We don't talk about how hot something is. We talk about the heat of something. We don't say how fast are you moving. We say the velocity. So it is a language that you guys must practice to use. So it's the same thing. So in this case, let's continue. I've got 5. It's pent, and I know that on the third one, 1, 2, 3, and 1, 2, 3. So on the third one, that is where the double bond O is. And if something is a ketone, according to the IUPAC system, the name ending should be ON, should be O-N-E. And that is then how we would have gotten that one. This was actually a nice question paper. So let's look at another question. Let me write down the next question. So the next one says, and this is 2.2.3, it says the structural formula, okay? The structural formula of its functional isomer. Ooh, functional isomer. Okay, so this, we're going to have quite a lot here. Functional isomer. Remember, guys, when we talk about isomer, this was also for 2 marks. When we talk about isomer, you must try and move that functional group, its position, to as many places as you can get. Because sometimes in an exam, they might ask you, how many functional isomers does this molecular formula have? And then you'll have to sit in the exam and try to find as many of them as possible. Guys, remember, if you are not sure whether something is its functional isomer or you've done it at the same time, you must name them. Because they can say, find the number of functional isomers that they are and give or provide the names for these structural isomers that you have found. So if you are kind of feeling a little bit shaky, always make sure you go back and you name it to simplify things or to check if you have actually answered the question. But in this case, they say we must write the structural formula of its functional isomer. So now, I'm going to do the first one. Let's see how many we can get. We have 5 carbon chains. So let's see, we have 1, 2, 3, 4, 5. Now we have to do what we haven't done. In this one, originally the O was on the 2nd carbon. In this time, I put it on the 3rd carbon. So what if I put this O on the last carbon? I can put the O, it hasn't been on the last carbon. So that is the one structural, that's the one isomer that we can get. It hasn't been on the last one. And remember, if it's on the last one, it means the name might change, right? And then I'm just going to need 1 hydrogen on this one, right? That's what we have. Let's see if we can have another one. Let's use blue. Let's have a second one. Let's see, I can say 1, 2, 3, 4, And then on the first one, because I've already put on the second one, on the first one I can put an O there, and then I can give this a side chain and put it there. Let's see. Then my longest chain is, if I count here, 1, 2, there's a side chain, and then here 1, 2, 3, there's a side chain. So then I can just put my hydrogens. Okay, that works. So I haven't had a side chain in any of the ones. And there we are. Put all your hydrogens there and so forth. Let's see if we can find another one. See if we can find another one. Let's use this one. So let's see, because we've got 5. 1, 2, 3. I can have 2 side chains on this one. Let's see if this one will work. I can have 2 side chains, and then I need to have an O somewhere. Let me keep the O here. Now let's see. My longest chain will be 3, but on the third carbon, or 1, 2, on the second carbon, rather, I'm going to have 2 carbons. So I'm going to have dimethyl there. There we are. So, and then I don't think I can move it any, however, again. Well, in this case, it was just for 2 marks. And they just said draw the structural isomer. They didn't really give us a number, but this is as many as I can come up with. I don't think we can move it anywhere. How? Let's see. Let's see if we move this one to the second one, we're going back to the first one. If I was to move this one to the third one, we're going back to this one. Let's look at this one. If I was to move this side chain here, it's still the longest chain. Aha! I actually just thought of something. Another mistake that you guys make is that, remember, even though a chain curves, it still makes it its longest chain. Let's actually just deviate a little bit, and let me show you what I'm talking about so that you can just understand a little bit further with what I'm saying. For example, with this one, if I was to put a carbon there, this still makes it my longest chain. This is not correct because it goes dun, dun, dun. So this one here will be exactly the same as this one. Just because it bends doesn't mean it's not a longest chain. So now, my darlings, for this one, I can actually only just find these 3. And it was only for 2 marks. So this is just the different structural formulas for these isomers. Okay, let's look at the next question for this one. And then now they're talking about we must consider the condensed structural formula. Now with you guys, one thing I've seen, the minute you see the condensed structural formula, you kind of panic. So we must consider the condensed structural formula. Condensed structural formula. Okay, now they've given this to us that we've got CH3, CH2, you've got a C, there's an OH there, and then you've got CH3, and you have another CH3. So guys, if you are having problems working with condensed structural formulas, what I always say in my classroom, somewhere on the side of your paper, redraw the structure. Because not everyone can actually see it like this to say, oh, okay, this one's a side chain, this one's this. And when you guys see brackets, you get very confused. Rather draw it somewhere if it's much more simpler to have the molecular formula with all the branches and all that stuff. If that is more simple for you, then rather redraw this, and then we're going to work on that, right? But don't worry, I'm going to try work on both as we answer this. So let's see what this question says. So we have this structural formula. And then the first question, 2.3.1. So this whole entire question is actually for 16 marks, guys. And we're actually not that bad. So now they're asking, is this a primary? Is this a, oh, this was an easy question. Is this a primary, a secondary? A primary, a secondary, or tertiary alcohol? Primary, a secondary, or a tertiary alcohol? Okay, and this one was actually also going for 2 marks. And then it says we must give a reason. Okay, so I think the best way for me to do, I'm going to first explain what is primary, secondary, and tertiary alcohol, and then based on what I've explained, we can see whether there's a primary, a secondary, or tertiary alcohol. You must remember, it's all about the parent chain. I'm going to write it like this. Primary. So this is U in primary. You attach to an OH. This is secondary. I'm going to show you how we'll fill them in. This is again U. Now you are in high school. You are doing your second phase in school. Then you've got tertiary. Tertiary. And this is you. So you are the COH the whole time. Tertiary means your third level. Remember, primary, you're in primary school. And what does primary school mean? You have only done one phase, right? So in a primary alcohol, you've got the main part, which is COH, attached to one carbon. Primary school. You're moving off to secondary school. So now this is you, but now you've done primary school and then you've done secondary school. Tertiary alcohol, this is you. You've done primary school, you went to secondary school, now you are in tertiary. So primary, secondary, and tertiary means how many carbons are you attached to, right? If you look at the first one, the main carbon is only attached to one carbon. The main carbon is attached to 1, 2 carbon. The main carbon is attached to 1, 2, 3. Primary, second for secondary, third for tertiary, and that is how you're going to remember it. So let's look at this one. So I'm actually going to redraw it, and then let's see if we can understand it. So we've got 1, 2, 3. This bracket means it is a side chain somewhere. Then it's got this one. So we've got 1, 2, 3, 4 carbons in a chain. I've got 1, 2, 3, 4 carbons. And then on the third carbon, I've got an OH. And on the third carbon, I've got a methane, right? And I've got 3 hydrogens attached to it, like that. An H and another H. And then this one's already got 4. I've got another hydrogen, another hydrogen. Okay, and there's my organic molecule. Now let's see, where is the parent chain? This is you. Now let's see how many are you attached to. You've got carbon number 1, carbon number 2, carbon number 3. If you are attached to 3 other carbons, tertiary for 3, this means this will be a tertiary alcohol. Tertiary. I hope you will never forget this. A tertiary alcohol. And how do we know this? Because the main carbon, the carbon that is attached to the OH, has got 3 other carbons attached to it. And according to chemistry, when the main carbon has got 3 other carbons, it is associated, or it is said to being a tertiary alcohol. So this is then how they wanted us to do it. This is actually pretty simple, and you can see it was only for 2 marks. And remember, if you don't know how to look at this, rather redraw it in this method, and then you can answer. So that was a very interesting answer. Let's see if we can do another one. So the next question says, this is 2.3.2. So we must give, we must give the IUPAC. Can you see how much we're using IUPAC? IUPAC name of the above compound, of the above compound. And this one's also pretty easy. It's for 2 marks. Okay, what I'm going to do again for my my darlings, and let's redraw it. We've got 4 carbons. It's attached to an OH. Let's put our hydrogens. I know these hydrogens take a little bit of time, and you can feel frustrated in exam writing hydrogens the whole time, but it's worth the marks. So there. Now, one thing you need to remember, or how I always teach my class, when you are naming something, the first thing that I actually wish we can write down the steps, but I hope you remember as I talk. You must always look for your longest chain, and then you look for any side chains that might be there. Then you look for the types of functional groups that might exist, or the homologous series in which it would belong to. And then you must look for any double bonds, triple bonds, and so forth. And then the last step is to put everything in alphabetical order. One of the biggest mistakes that learners do, or what examiners pick up, is that you do not put things in alphabetical order. Now remember, you can have negative marking and you can lose marks if you don't do that. Because it means that you understand the IUPAC system, but to a point where you forget to number things in alphabetical order. And remember, guys, if you can find everything, it's only the last step to put everything in alphabetical order. So let's see how we're going to name this one. So they want us to give the IUPAC name for the above system. Let's see, how many do we have? We've got 1, 2, 3, 4. We've got 4 means but. Remember, it's meth, eth, prop, and then but. 4 is but. So let's see. The next thing we need to say, Tobile forgot her side chain. This is on this carbon here. Now I'm looking at this exam and I'm thinking, where did that come from? Here we've got a C and it's got hydrogens there. There we are. Yes, I forgot that one. So now let's see. We're going to name this 1, 2, 3, 4. Remember, your side chain and your functional group must always get the lowest number. So, Billy, what do you mean by this? Look at this. If I was to number this 1, 2, 3, 4, if I numbered it in this way, my functional group and my side chain will have number 3. But if I number it in the green, 1, 2, 3, it'll take 2. It must always take the lowest number, right? The same way we always look for the longest chain, we always find the lowest number. And remember, whether you number from the left to the right or the right to the left, it doesn't really matter. You must just make sure that your side chains and your functional groups will always have the lowest number. So in this case, I'm going to use the green. So I can then say on my second carbon, something is happening on my second carbon. And what is happening? On my second carbon, I've got a branch and one carbon is meth. But remember that we twang it a little bit and write methyl, right? And again, on my second carbon, what is happening on my second carbon? I've got ol. Now, we've got OH, right? What does the OH mean? It is an alcohol. And the name ending for anything as an alcohol or the functional group under alcohols must end with an ol. The same way aldehydes will end with ol. Carboxylic acid will end with acid and so forth. So on the second one, it must end with a ol. Now let's put things together. Remember, we must put things in alphabetical order. You must always start with your side chains. So on my second one, I've got methyl. But what is my longest chain? There, it's butane to ol. Right? But then let me see, there's also another way you could have actually added it, where you can actually move this 2 to come between these two. Okay, let's see how we're going to do that one. So here we can have 2, so it's not wrong, but obviously you can't say 2-ol, 2-methyl, no. But what you can do, you can actually show that between the methyl and the butanol and the butane, there's something there. So we can say 2-methyl, 2-methyl, 2-butanol. And let's see whether we're correct with this one, right? This is how I always verify whether something is correct. Remember, there's a lot of things to remember in physics, so make sure that we always get it right. My longest chain is but. But means 4, 1, 2, 3, 4. On the second carbon, I've got an alcohol bonded on it. On the second carbon, I've got an alcohol bonded to it. On the second carbon again, I've got methyl. On the second carbon, I've got methyl. Now, you're probably asking me, Tobile, why didn't you say 2.2 di something? Remember, we can only say di something if we had 2 methyls that we bonded on the second carbon. But now we've got a methyl or a methane, right, in singular terms, and then we've got an alcohol, which means they are not the same thing. But we know on the second carbon, there are 2 things that are bonded on there, but they are not the same. So you cannot say 2.2. You have to separate it to say on the second carbon, I've got a 2-methyl. Again, on the second carbon, I've got an alcohol bonded, but my longest chain is but, which means 4. And that is then the IUPAC name for it. And it was only for 2 marks. But then again, remember, if you do not put your hydrogens, if you do not have your hyphens in the correct place or your commas in the correct place, you will lose marks according to the examiners. And I mean, it's only 2 marks, guys. So let's try bank those marks. Let's see. Let's go to another slide. Okay, we have another question with this one. This looks like an interesting question. This is 2.3.3. And it says, so here we've got the IUPAC. This question had a lot of IUPAC. The IUPAC name of the major. Oh, I see. Already when you talk about major, you must think of rules of the major organic product, of the major organic product formed. Of the major product formed. And this is when this compound undergoes elimination. Okay. So I actually want to redraw it, guys, so that we know what we're talking about. Got C, I've got another C, another C, another C. Remember, we had a methane there. We had a methane there, and then here we had an OH also attached to them. Okay, and then I'm going to reread the question, and then we can start examining what the question says. We must give the IUPAC name of the major organic compound. Now, guys, most of you guys not really get confused, but there are two theories that we need to remember when we talk about major and minor products. When we talk about major products, these are the products that are most likely to happen during this reaction. And the minor products are the products that are less likely to happen, right? Now, what does this mean in chemistry? So this means there are a lot of hydrogen, so we can eliminate any hydrogen, right? But then we need to go back to a guy called Markovnikov, and we also need to go back to Zaitsev rule. And they are the ones who can actually help us when do major products form and when do minor products form. They can also help us to say which hydrogen do we lose, which one do we gain, and then so forth. So in this case, they say we must give the IUPAC name of the major organic compound formed when this compound undergoes elimination. Now, when we eliminate something, it is to remove, right? So, for example, in soccer, when they are playing, I think there's 11 players. They are playing in soccer, and then somebody gets a red card, you know, you are eliminated off the ground. We don't replace you with somebody else. You are eliminated. Now, your team only plays with 10 players. The other team will only play with 11 players. So it means you are one man short. In an elimination reaction, right, whether you are dehydrating water or you're removing a hydrogen gas, you are losing your hydrogens, right? Now, when you remove your hydrogens or you eliminate something, in organic chemistry, we must form a double bond or we form a triple bond. Right? So you must always keep that in your mind. Always think about Markovnikov and Zaitsev's rule, and they are the ones who will then lead us. But now let's see what they want us to do here. So the IUPAC name of this major one that then happens. So now remember, if something is being eliminated, we eliminate for the major product on the carbon with the lowest number of hydrogens, right? We eliminate, let me actually make a little note for you guys here. The major product, always remember it if you see a question like this. Major product is formed where, can phrase this as simple as I can, is formed where the atom, oh, my pen's not writing. It's formed where the atom, let's try that again, where the atom is removed from the carbon with the least hydrogen atoms. So between these two, I can see that this is the one. I've got a hydrogen here, a carbon which is a neighbor, and one that is there. But according to the major rule, this is now Markovnikov and Zaitsev's rule, the major product is formed and it's removed from the carbon with the least number of hydrogens. I've got 2 hydrogens on this one, and I have 3 hydrogens on this one. The least number of hydrogens mean I'm going to remove it from this one. When we remove from this one, we then form a double bond. So now let's see. Now, just by mere looking at, or just looking at let me just go to the previous slide. By looking at the name that we were given here, oops daisy, if we look at the name that we were given here, the most important thing is that the alcohol part will then change to show that it moves or it becomes a double bond, right? Remember, if we are eliminating something, we'll eliminate the H from the carbon with the least number with the OH, and this will form water, and this will then form a double bond. So now it means we take the same number on the second carbon. I've got a methyl, but now remember your OH and this H move and they give us water. You still have your longest chain, which is 4 carbons, which is but, we know that on the second carbon now, on the second carbon, we're going to have a double bond. So on the second carbon, we're going to have a double bond because remember, in soccer, you eliminate and then you have less players. In chemistry, you eliminate and then you form a double or a triple bond. In this case, we're forming a double bond. And how do we show a double bond? The name ending must change to show that it now doesn't belong to alcohols ending with "ol." It now ends with "ene" to show that it's an alkene. So on the second carbon, we have a double bond. How do we know this or how do we identify? We say "ene." There we are. So it remains exactly the same. Let me take you through it. On the second carbon, I've got a side chain, which is methyl. On the second carbon, we name this 1, 2, 3, 4. Second carbon, I've got a methyl. How many carbons are in my longest chain? But means there's 4. On the second one, the side chain becomes, the single chain becomes unsaturated, and then this H and this one will be eliminated to form water, and then it becomes an ene. So we can see that we've already changed its functional group. It moved from an alcohol all the way to an alkene.